Hello folks, and welcome to Leetcode, where we talk about algorithms and different data structures. Today, we're going to have a look at a problem that is called valid parentheses. It is labeled as easy on Leetcode, and it is quite a common interview question, so there is a very good chance that you're going to be asked to solve it. So let's have a look together. We have a string S which contains several characters, 6 to be exact, and all of them are different types of parentheses. We've got parentheses themselves, we've got curly braces, and also we've got brackets. And we've got an open one and a closed one for all of them. And to determine if the string is valid, because that is the main goal of our problem, we need every open bracket, as here, to be closed, but not just to be closed, but be closed by the same type of brackets. And it must be done in the correct order, and every closed bracket has a corresponding open bracket of the same type. So let's have a look at the examples here. That is our string S, and we've got an open parenthesis and a closed parenthesis here. And we need to check if it's valid. What do you think? We return true, so we consider it is to be valid. Why? We have our first element of the string, which is an open bracket, and then the second element of the string is a closed bracket. So are they of the same type? Yes, they are. Are they closed in the correct order? Yes, they are. And do they correspond to each other? Yes, they do. So that's why we return true, because it's valid. But what if our string consisted of these two elements? What if the first element of the string was a closed parenthesis, and the second, the last element of the string, was an open one? Would we return true? No, of course we wouldn't. Because if we look at the first element, it is a closed parenthesis. Does it open anything? Does anything go before it? No. And the second element of the string, does it close anything? No. It opens, but it's never closed. So we can't return true. It is invalid, and we will return false. Now, let's have a look at our example 2. Here we have 6 elements. We've got open and close, and again open and close parentheses. They are given in the correct order. We start with open, we finish with close. They are given in the corresponding order, so every open has a close one of the same type. That is why we consider the string to be valid, and so we return true. And our last example that is given here, our string consists of 2 elements, open and close parentheses, but there is a catch. Are they of the same type? They're not. The first element is an open parenthesis, right? But the second one, which is a close one, is of different type. It is a closed bracket. So the order is okay, but we don't have corresponding types here. They are not the same. That's why we cannot say that the string is valid and our output will be false. So what algorithm do we need to solve this problem? Let's have a look at our problem one more time. So our string has to be valid, and in order it to be valid, we have to start with an open parenthesis. Can we ever start with a closed one? What do you think? No, we never can start with a closed parenthesis because we can never ever have anything before it to close, right? So it doesn't matter how many open or close ones I've got after it, it's never gonna be valid. But if I start with an open one, it doesn't matter how many of them I have, as long as I close them at the end. So we only have to start with an open parenthesis of any kind, and once we start with it, we can add as many opening as we want to, as long as we are closing them at the end. So that's clear. So if we have 2, 3 open parentheses, we have to have 2 or 3 or 4, doesn't matter, the closed ones that come after them. And when we are adding those closed parentheses that match the open one, they kind of neutralize each other, right? So we can cross them out from our list. And then when we added this one, it neutralized the previous one. And the last one neutralized the very first open parenthesis. So once we are done removing everything, and at the end, as you can see, we have an empty list. So we know we can return true. So we basically closed all our open parentheses and they matched each other. So now let's decide what data structures we are going to use to solve our problem. As you can see here, I've already chosen stack and HashMap. Stack is going to be the most important part of our algorithm, and HashMap is going to be very helpful. So it's not necessary to use it, but still quite helpful. So we'll start with HashMap. Okay, so what we're going to do with it? We're going to put all the characters, all possible characters that can be in our input into keys and values. So all the opening characters, opening brackets, opening parentheses, curly braces are going to be in our keys, and all the closing ones, closing parentheses, brackets, curly braces are going to be our values. Okay, so let's look at the example that I wrote here. And we are going to look at the very first element of our string. So my very first task will be to compare my very first element to the keys in my HashMap. So I look at my very first element, I compare it to the keys. Do I find it in my keys? Yes, I do. It is there. So what I'm going to do next, I'm going to push it into my stack. Then I continue with the second element. I compare it to my keys. Is it there? Yes, it is. And I again push it to my stack. Then I continue with the third element. Compare it to my keys. It's there. Yes. And I push it to my stack. And now we'll see the magic of our algorithm. We'll look at the next element and we again compare it to the keys. We don't see it in our keys because now what we have in our string is the closing parentheses, right? So my very next step will be to pop my very top part of the stack, top element of the stack. So it pops and it goes here. And now my task is to compare that this top part of my stack with my current element of the string. Okay? And if they match, so I go again to my HashMap, I look at my top stack element and then I look at the value. And if this value is the same as my current element, that's wonderful. That means that they match. So now I'm going to have only 2 elements in my stack. And then I continue my work. I go to the next element of my string. I look at it. I compare it to the keys. There is nothing that I can find here. So what is my next step? Yes, correct. I take my top element of the stack and I pop it. It goes here. And then I compare it to my current element of the string. So I look to my keys. There is my top part of my stack. And I compare it to my current element of the string. Do they match? Yes, they do. Wonderful. Crossing it here. Now I have my final, my very last part of my stack, and I continue my work with the very last ingredient here, very last character. And the same work, actually. I compare it to the keys. It's not here. What I do next, I again pop. It's here. Sorry for my drawing. And I compare my very last component to the keys. They match. Wonderful. So what we're going to have here is an empty stack, and if my stack is empty, then it means that my input is valid and I can return true. If we look at another example that I've got here, and we follow the same procedure, look at the first element, compare it to the hash map, keys, yes, it's here, push it to the stack. To the next element, it's here, push it to the stack. Next element, it's in the keys, push it to the stack. Next element, compare, it's not in the keys. So what I do to my stack, I pop the top element and then I compare it to my current element in the string. Right? So I look at my keys again and then I look at the value. Is it the same as my current element in the string? No, it's not. So the string latest element is not okay. They do not match. So we can stop right here because now the input is not valid. And we will return false. So now let's get to our code. And the first thing that we're going to do is to create map, the hash map, where we will put all the characters possible and open parentheses as the keys and closing parentheses as the values. Then we're going to create stack. So the new stack is here. And we're going to push characters in that new stack. And for that, first we will need to iterate through all the characters in our string. That will turn into an array here. And we're going to have options, of course. So option 1, if our current character is in the keys of our map, then we just push it to the stack. As simple as it is. But if it's not, because it's a closing parenthesis, for example, then we're going to create a variable, open, let's call it that, where we put the value of the top element of the stock, which we pop. And then we're also going to have some options. So first, we use open variable as the key in our map, and we compare it to the value, and if its value is the same as our current element, it's okay, we just continue. But if no, we can return false. Another thing that we need to check before we do everything here, we're going to need to check if our stack is empty. And we do it because, for example, we have a string that consists only of closing parentheses. So we are not going to push anything to our stack, and that means that we will have to return false and our string is invalid. And we're going to do the same at the very end of our code. We, again, are going to check if our stack is empty, because if it is empty, we can be sure that we processed all the characters, we'll look through all the characters in our string, and it's okay, so we can return truth. The last thing that I want to discuss is time complexity and space complexity. So time complexity, both, and space complexity are going to be big O n. Time, because we go through all the elements in our string, and space, because in the worst case scenario, we will have to push all the elements of our string. And now we submit and we check that it works pretty well and everything is good here. Thanks for watching and see you in the next videos.